In this video, we will be discussing bisectors. We'll be talking about the equations that arise when we have a bisector or a midpoint. These are things that split angles and segments exactly in half. So let's look at the given. First of all, angle CAB is a right angle. You can see that, you see the little box right here. Angle CAB is this angle right here. That is a right angle. By the way, that automatically means that angle CAF is also a right angle. All right, you have to have back-to-back right angles in a situation like this. So just keep that in mind. I'll come back to that in a moment. Also, we are given that point A is the midpoint of segment BF. So they are telling us that point A is the midpoint. So that means that this segment BA and this segment AF, those are going to be equal. So keep that in the back of your mind. Finally, they tell us that segment AD bisects angle CAE. Bisect means to cut exactly in half. So where is angle CAE? Here's angle CAE right here. You know what? Let me do this with a pen. Okay, here is angle CAE. So if segment AD bisects this, that means that this segment right here cuts the angle in half. All right, so that means that this angle and this angle will be equal. They will be congruent. So that is all the information that we are given. So just keep that in the back of your mind as we discuss. So look at the distance between B and A, and look at the length of segment BF. Okay, so BA is right here, and look at BF. Okay, so BF is this. All right, so the red is BA and the green is BF. How are those going to be related to each other? Remembering that A is the midpoint, that means that the red is half as big as the green, or the green is twice as big as the red. Okay, so now let's use the star and the heart. So BA is the star, so I'll put that right here. And then BF is the heart. Okay, so I'll put that right here. So are these going to be equal? No. All right, the green is bigger than the red. The heart is bigger than the star. These are segments, so it will have nothing to do with 90 degrees or 180 degrees. How about this one, though? Okay, this seems like it's going to be true. Because if this is star over here, BA, then that means this will be another star over here. All right, those two will be the same. So star plus star is going to equal the heart. All right, so that's a true statement. All right, part plus part equals whole. All right, how about the next one? All right, now that we have the idea, I'm going to go a little bit faster. So BA is the star. So let's stick with that. Now, how about FA? Okay, FA is the heart. Well, these should just straight up be equal to each other. So star equals heart, boom. That's all there is to it. All right, look at number 3. All right, now we're getting into angles. So we might have some of these degrees might be happening. We'll see. Angle CAD is the star. Okay, so angle CAD, that's right here. Angle CAD. That's the star. Angle FAD will be the heart. All right, FAD is right here. I'm trying to put them side by side so you can see. Okay, these will not be equal to each other because remember that, what did they say? Remember that AD is the bisector. So don't forget, AD is the bisector. But the angle it's cutting in half is angle CAE. So CAE is right here. So these two parts are equal. The star is equal to this angle right here. The star is not equal to the larger green angle that we put a heart on. So they're not equal. So get that out of your head. However, we have a 90-degree angle over here. See this right here? This is a 90-degree angle. It is back to back with the other 90-degree angle. So we know that this side is also 90 degrees. So the star plus the heart is going to equal 90 degrees. All right, got to start over. All right, this is like a fun little game. Angle CAE will be the star. CAE. Okay, so here is angle CAE, and that is the star. I'll put it real big. Okay, what's next? Angle DAE is going to be the heart. All right, so now we have angle DAE, and that's going to be the heart. Now, remember that segment AD is a bisector. So segment AD is cutting this angle, CAE, in half. So that means these two sides are going to be equal to each other. So that means that since these two angles are equal, we have the heart over here on the right-hand side. We could put a heart over here on the left-hand side too. All right, because of the bisector, this should be right in the middle, heart on either side. The star is the whole angle. So heart plus heart is going to equal the star. That's what we have. Okay, so for number 4, we see heart plus heart equals star. All right, number 5, angle CAE. That's going to be star. So there's angle CAE being a star. And then we have angle FAE will be the heart. So FAE is this down here. And that is the heart. All right, again, these are not equal to each other. The star is obviously bigger than the heart, but don't forget that this is a 90-degree angle right here. So that means that these two add up to 90 degrees. So star plus heart equals 90. Okay, so there you go. All right, next we have angle BAE is the star. Okay, so angle BAE. All right, so this right here is the star. Okay, what's next? Then we have angle EAF is the heart. Okay, EAF is this angle right here. And that is the heart. Well, this is a linear pair. Together, they make a straight line. So they have to add up to 180 degrees. So star plus heart equals 180 degrees. Kabam. All right, next we have angle CAD is the star. Okay, let's see. So angle CAD. All right, this is the star. Now let's see where the heart is. Angle EAD is the heart. All right, so angle EAD is the heart. And because AD we know is the bisector, all right, this is right down the middle, so that means star equals heart. Okay, so let's use those skills to write some actual equations that we will solve. So we are given that segment BD is a bisector and the angle bisector. So just keep that in mind. That means that these two smaller angles are equal. And so watch out for the following two situations. Sometimes we will have the situation where half is equal to half. All right, if I have the small angle and a small angle, those will be equal to each other. But other times we will have the situation where two halves equal the whole. So each time we do this, we'll have to ask ourselves which situation we're in. So let's identify the angles. We have angle ABD, and here's angle ABD right here. All right, so I think I'll put a red box around that, color coordinate. And then angle ABC is this angle right here, ABC. So I'll put a green box around that. So is this half equals a half, or is it two halves equals a whole? Well, this is going to be a situation where two halves equals a whole, because the red is half and the green is the whole. So we need to do two halves equals a whole. Okay, so we need to do, here, I think I'll switch colors. So we're doing two halves equals a whole. So that means 2 times the 4x minus 10, all right, 2 times the red one, is going to equal the whole, which is the green one, which is 6x plus 22. So that's the equation. Now we're just going to solve this by doing the distributive property. So we have 8x minus 20 is equal to 6x plus 22. When the variable is on both sides, we need to subtract one of them to get them together. So we have 2x minus 20 is equal to 22. We're trying to get x by itself. Oops. So we need to add 20 to both sides. So that'll give me 2x is equal to 42. And finally, we divide both sides by 2, and we get x is equal to 21. All right, so great. X is equal to 21. Now we need to plug this back in to find these angles. So angle ABD, first of all, so that's red, so maybe I'll use red. So angle ABD is the 4x minus 10. Okay, so I'm doing this one right now. So that's going to be 4 times 21 minus 10. Okay, so 4 times 21 minus 10. So that is 74. All right, so ABD is 74 degrees. Now, how about angle ABC? That's green. All right, so we're doing the green one now. That's 6x plus 22. All right, so I could do 6 times 21 plus 22. Or I could recognize that this green one is double. So I could just multiply 74 times 2. All right, I could just go times 2, 148. All right, I could do that. Or I could use the formula and do 6 times 21 plus 22. 6 times 21 plus 22. Either way, I get 148. All right, now, how about this angle DBC? What's that about? All right, angle DBC is this angle right here. But because of the angle bisector, these two angles are equal. So this angle DBC should match angle ABD. These are congruent. So if this is 74, then this will also be 74. Okay. BD is the angle bisector again. All right, we're same situation. So let's label these things. Angle DBA. DBA is this guy right here. That is DBA. Okay, so I'm going to mark that in red. Okay, CBD, I'm going to put in green. Okay, CBD is this angle right here. Here's CBD. Now, these two should be equal. All right, they're both halves. So this is a situation where we think to ourselves, half equals a half. All right, we have two halves. So that's why we're just going to set these equal to each other. So we will have 6x minus 2 is equal to 4x plus 16. Subtract 4x from both sides. So we have 2x minus 2 is equal to 16. Add 2 to both sides. We have 2x is equal to 18. And then divide by 2. You get x is equal to 9. So find x is equal to 9. Now we need to find angle DBA, which is here in red. So I'm going to go ahead and do the red. That's 6x minus 2. So that's 6 times 9 minus 2. Okay, so 6 times 9 is 54. So this is going to be 54 minus 2, which is 52. Okay, so DBA is going to be 52. And then it's time for CBD. For CBD, I could use the formula, but these are equal. So I know already that this is going to be 52. Now, angle ABC is the whole angle. So ABC is going to be like 2 halves equals the whole. So I just have to double this. So if I take this and I just simply double it, that's going to give me 104. And you know, all these should be degrees, I guess. Okay. For the last problem, they were not kind enough to give us a picture. So boo. Boo on that, I say. So we'll have to draw our own picture. All right, M is the midpoint of segment PQ. Let's start with the second part, segment PQ. So here is segment PQ. So here's P and here is Q. And then M is the midpoint. All right, if M is the midpoint, that means these two parts are congruent. So let's see what we're talking about. All right, PM is 9x minus 3. All right, so PM is this part right here. Okay, now PQ. PQ is this part right here. So we have to decide, are we going to use half equals half or 2 halves equals a whole? Well, PM is a half and PQ is a whole. So we need to use the idea that 2 halves equal a whole. All right, so that means that 2 times the PM, which is 9x minus 3, is going to equal the whole. The whole is the PQ, shown here in green, so that is 11x plus 22. Time for a little distributive property. We get 18x minus 6 is equal to 11x plus 22. When you have the variable on both sides of the equation, you have to subtract one of them. So this is going to give me 7x minus 6 is equal to 22. And now I'm going to add 6 to both sides. So that'll give me 7x is equal to 28. And finally, we divide both sides by 7, and we see that x is equal to 4. So x is 4. Now it's time to find PM. All right, so this is red. 9x minus 3, so we could just do, maybe I'll just put it right here. We'll do 9 times 4 minus 3. 9 times 4 is 36, and 36 minus 3 is going to be 33. All right, now PQ is twice as big. All right, PQ is double the length of PM. So when I do PQ, I could use this formula again, or I could simply double it. And that would make 66. And then what about MQ? Here's MQ right here. MQ is half. PM is half. These two are equal. All right, so if PM is 33, that means MQ is also going to be 33. So I'm just copying this right there.